All right, first question was number 81. 81. So it's solve the system by any method. So this is going to be, let me see here. Okay, it's x plus 12y equals 68. And then it's x equals 8y minus 12. Okay, because x is already isolated in the bottom equation, I'm going to take this 8y minus 12 and I'm going to plug it in. I'm going to use the substitution method. So what I get is I get 8y minus 12 plus 12y equals 68. These two can combine. I get 20y equals, if I add 12 to both sides, I get a 0, I get an 80, so y should equal 4. So far so good? Now from here, I'm not done yet, I just found y, so I'm going to go ahead and find x. Since x is already isolated on the bottom equation, I'll just put it there. So x is equal to 8 times 4, which is what we just found, minus 12. Well, 8 times 4 is 32, so x should equal 20. So your final coordinates of intersection should be 20, 4. Any questions about 81? Good. All right, so let's take a look at number 85. Tell you what, can we save 85 for the end? It's a 3 by 3 problem. Can we save 85 for the end? All right, 101. Excellent problem. 8 minus I squared minus 3 plus 2I squared. Okay, please bear in mind that this is not 64 minus I squared. Okay, this is 8 minus I times 8 minus I minus 3 plus 2I times 3, plus 2I. And it's actually minus the whole thing. So let's go and FOIL this out. This is 64 minus 8 16I plus I squared. What is I squared, everybody? Negative 1. So this is minus 1 here. So I should get 63 minus 16I. Now I'm going to go ahead and do the same thing here. I'm going to get minus, this is going to be 9, plus 6I, so that should be 12. I'll just do it here. And then plus 4I squared. Well, what is I squared again? Negative 1, so this is minus 4. So this is 5 plus 12I down here. And that's all being subtracted from 63 plus 16I. Now I'm going to go ahead and distribute in my negative sign, so I get negative 5 minus 12I. And then 63 minus 16I. Where's my engineer from Chuck E. Cheese? Chris. 16 minus 12. I. $28I. Do you need your vacuum? What's 63 minus 5, Chris? 58. Thank you. 58 minus 28I. Not bad for an engineer from Chuck E. Cheese, Chris. Good. All right. An electromagnetic, mechanical, technical service diagnostic engineer. That was 101, right? So 113 now? 2x to the 3m over negative 6x to the 2m squared. Okay, this one's hard because there are variables in the exponents. But remember, they're never going to give you something that you can't do. Right? It's just going to push you in the things that you know. So I know the top is going to be the same. Well, the bottom's being squared, so that negative 6 is going to turn what? The negative 6 is going to turn what? Because it's being squared, it's going to turn positive, 36. Now, x gets raised to a power. So 2m to the second power is to the 4m. So from here, I can go and just start reducing. 2 into 36 is 1 over 18. Now, here's where the variables are going to start to become really, really easy. X to the 3m minus x to the 4m is x to the negative m. But since it's negative, it's going to remain where? On the bottom. There you go. 153. Ah, yes. Yes, we don't have that. That is Teacher Mariano right there. This is really testing your ability to factor. Because most people are going to look at this and they're going to be like, oh my god, what's happening to her? Right? And why can't I move? There must be a logical reason for all this. What do they all have in common? They all have an x plus 2, which means I can factor out an x plus 2, leaving me with x squared minus x minus 12. Now what can I do? What can I do with this thing? Elise, what do you think? No, distributing it would get me back to where I started. Daniel, what do you think? Refactor this. This is x minus, looks like 4 times x plus 3, and all that is being multiplied by x plus 2. That one's a pusher. That one will push you. 172. Ah, yes. Yes, yes, yes. Let's see here. 4x to the negative 1/3 plus x to the 1/4. Oops, I'm sorry, not minus. Should just be x to the 1/4 y to the 2/3. Okay, all over x to the 1/3. Okay, so now, a couple different ways we can do this. I'm going to do this the separation method. Remember how if they're all being added together and they're all under one denominator, I can split them apart? Everyone remember this? Okay, well, this x to the 1/3 here is going to move down and become 4 over x to the 2/3 plus, hardest part about this is finding a common denominator. So my common denominator is 12. So if I say x to the 1/4 divided by x to the 1/3, this is 1/4 minus 1/3. So that is going to be 3 over 12 minus 4 over 12. So that is negative 1 over 12. So this thing here becomes x to the 1/12 but on bottom, and I get y to the 2/3. So if I clean it all up, I'm going to get 4 plus y to the 2/3 over, oh wow, I would need a common denominator here too. Forget it, too much work. There you go. All right. Let's see here. 105, I believe, was the mother problem, right? Mother. Mother 2. Earthbound. 85. Oops, not 105, 85. Okay. X plus 2y minus z equals negative 8. 2x plus y minus 3z equals negative 10. And then negative 3x minus y plus 2z equals 6. All right, we need to figure out which one we're going to get rid of. Trevor, what do you want to get rid of first? I think y is a good choice. So why don't we use 2 and 3 first? So we'll say 2x plus y minus 3z equals negative 10, and then negative 3x minus y plus 2z equals 6. So we're going to get rid of y. I've got negative x minus z equals negative 4. Now I put it in the box. We got to get rid of y one more time, so I'm going to go and choose 1 and 3. So x plus 2y minus z equals negative 8. I'm going to multiply this by 2. So I get negative 6x minus 2y plus 4z equals 12. Bam, those go away. I end up with negative 5x plus 3z equals 4. Those are the two 2x2s that I'm going to stack up against each other. So I'm going to multiply the top by 3. So I get negative 3x minus 3z equals negative 12. Negative 5x plus 3z equals 4. Those are gone. I end up with 8x equals negative 8. X equals negative 1. Woohoo! It's always the first one that I get really, really nervous about. I'm like, oh, God, just cross my fingers that the first one works. Now, I am at the third level of inception, right? I am in the elevator. Now I'm going to climb my way back into the snowmobile fight, which is this layer of inception. So I'm going to go and plug it into the top one, so it's going to be Daniel. Oh my gosh, I almost non-incepticized myself. Thank you, Daniel. Okay, so now x equals 1, so I'm going to get negative 1 minus z equals negative 4. So negative z equals, looks like negative 3, so z equals 3. Daniel, thank you. That was huge right there. Because I think z would have ended up okay, but I think y would have ended up really messy and would be like, oh, what happened? Okay, so now we just left the snowmobile fight. Now we're going to enter into the car falling off the bridge, right? Inception, right? So I'm going to go ahead and just plug it into the top one. So that's going to be 1 plus 2y minus 3 equals, I believe it was negative 8. I know it's getting kind of messy. So this is negative 2, which I'm going to add to both sides. So I get 2y equals negative 6. Y equals negative 3. Daniel, how am I doing? Good? Okay, so my final answer should be 1, comma, negative 3, comma, 3. Alright? Cool. I'm going to pause this thing. We'll come back in a little bit. What number 118 is asking you to do is it's asking you to find the value of n that makes the overall statement true. Now, we have to use our properties of exponents in order to simplify this left side here. If I have the same bases up top and bottom, and I have exponents up top and bottom, does it make sense that I can combine this into a single exponent or single base with an exponent of n minus 15? Does that make sense, everyone? Right, because they're being divided, so the exponents are being subtracted. And that's going to equal, well, I have 3 being raised to this power, so the exponents are going to multiply each other, so it's going to be x to the 3n plus 6. Does that make sense, everyone? Yeah? Okay, so now that the bases are the same, does it make sense that the exponent should also be the same? So n minus 15 should equal 3n plus 6. Yes? So if I subtract n from both sides, and I also subtract 6 from both sides, I'm going to get 2n equals negative 15 minus negative 6 is negative 21. So n should be negative 21 over 2. So that was 118. That's a good question, actually. I really like it. It's quite challenging. That was number 118, so 161. Okay, 161. They are just going to give you a rad 3 over a 6 minus rad 3. Do not do this. Don't do that, please. Please don't. That's definitely not correct. Although the idea is actually not that bad. You're trying to get rid of the radical in the denominator, but that's not the right way to do it. How do you get rid of a radical inside the denominator? Cameron. Conjugate. Daniel, do you know what the conjugate of 6 minus rad 3 is? 6 plus rad 3. So now, what I get is 36 minus 3, which is 33. And now I just got to multiply this in. So this is 6 rad 3 plus rad 3 times rad 3 is 3. So you can leave it like that. Oopsie. Alright. So that was 161. 182. 7 minus 5x to the 1/2 equals 8. Okay, I'm going to let you guys in on a secret. 7 minus 5x to the 1/2 is the same thing as saying the square root of 7 minus 5x equals 8. How do I get that square root out of there, Porter? Square both sides. I got 7 minus 5x equals 64. Negative 5x is going to equal, if I subtract 7 from both sides, I get a 57. And then I get x equals negative 57 over 5. Please don't forget to check your answer. Okay? Because, let's see if it works out. The square root of 7 minus 5 times 57 over 5 equals 8. Those are going to go away. You get 7 plus 57. That's 64. Does the square root of 64 equal 8? Yes, it does. So we check it off. Remember, you have to check to make sure that it works. Otherwise, you're not going to get full credit for your problems. That was 182. 183. Rad x minus 8 equals rad 13 plus x. Square both sides. X minus 8 equals 13 plus x. Well, the x's are going to cancel each other out, and I get negative 8 equals 13. How often is that statement true? How often does negative 8 equal 13? Never. So the answer, AJ? No solution. Very good. 199. X to the third. This is a good problem. X to the third minus 64x equals 0. Okay. Zero product property. Just factor things out. So this is, if I factor out an x, I get x squared minus 64 equals 0. How does the inside factor? Borna. Okay, we didn't cover zero product property. This is more chapter 6 stuff. But anyone know what does x equal in all three conditions? For this to equal 0, what has to be true? What does x have to equal on the left? Ilias? Okay, it has to equal 8. Actually, you know what? Let's just do this. Since all three things are being multiplied together and they equal 0, I'm going to say x equals 0, x plus 8 equals 0, and x minus 8 equals 0. So here x equals 0, duh. X equals negative 8, and x equals 8. Raise your hands if that looks familiar, like from Algebra 1, like you've done that before. Maybe on a smaller scale, they didn't have you do with a cubic function. 110. Let's go back. Eight over x to the 0 plus 3y to the 0. What's anything to the 0 power? 1. So that's 8 over 1 plus 3. So that is 8 over 4, which is 2. Yes? Okay. Very cool. Numbers 86 and 99 we've already kind of done. There was one that was a 3x3 system. There was that was another one, so we'll just go and pass on those. All right. I'm going to go and start compiling this real quick.